Imagine a time long, long ago, before houses, before towns, and even before farms. You are a shepherd named Og. Your job is to look after your family's flock of sheep. Every morning, you lead them out to the grassy hills to eat. Every evening, you bring them back to a safe pen. One evening, you look at your sheep. It seems like there are fewer than when you started. But how can you be sure? You don't have a way to count them. You just have a feeling. This was a big problem for early humans. They needed a way to keep track of important things like sheep nuts days until the next full moon. So, Og had an idea. He picked up a small stone for every sheep that walked out of the pen in the morning. He put these stones in his leather pouch. When the sheep came back at night, he took one stone out for each sheep. If he had stones left in his pouch, he knew some sheep were missing. Long before we had pocket calculators or smartphones, people carried a fantastic counting machine with them everywhere they went. What was it? Their own two hands. Using fingers to count feels completely natural, doesn't it? We still do it today. A young child will hold up 3 fingers to show you how old they are. This is probably the oldest counting system in the world. It's easy, convenient, and you never leave it at home. Most early cultures used their fingers to count. They also used their 10 toes. That made 20. Other groups developed clever finger counting systems. They turned their hands into a sophisticated counting tool. No need to carry a heavy bag of stones. As trade and communities grew, people needed numbers that lasted, so people invented tally marks. Let's travel forward in time to the land of the pharaohs and pyramids. Ancient Egypt, around 3000 BC. The Egyptians were amazing builders and organizers. To build a pyramid, you need serious mathematics. They developed one of the first written numeral systems. Instead of tally marks, they used pictures called hieroglyphs. Here's the chart of hieroglyphs for their numbers. For the number 1, they used a single straight line. For 10, they drew a picture of a hobble, a rope to tie cattle legs. For 100, a coil of rope. For 1000, a lotus flower. To write 235, they would draw 2 coils, 3 hobbles, and 5 straight lines. The order didn't matter. You could draw the 5 lines, then the 2 coils, then the 3 hobbles. Imagine trying to write 999. That's many pictures for one number. Doing calculations must have been very time-consuming, but the Egyptian number system worked for them for thousands of years. They used it to build magnificent temples and to calculate taxes, land after Nile floods, and more. They showed the world that a good number system was the key to organizing a great society. Now let's journey east from Egypt to a place called Mesopotamia, the land between the Tigris and Euphrates rivers. The Babylonian civilization was flourishing. They were incredible astronomers and mathematicians. They based their system on the number 60. We still use their system every single day. 60 seconds in a minute, 60 minutes in an hour. Why 60? Well, 60 is a fantastic number. You can divide it evenly by 2, 3, 4, 5, 6, 10, 12, which makes it great for trade and astronomy. The Babylonians wrote on soft clay tablets using a stylus, making wedge-shaped marks, cuneiform. They had only 2 basic symbols to create all their numbers. A single down wedge meant 1, a side wedge meant 10. The brilliant part, their system was positional. The value depends on where the symbol sits. They used columns for 1s, 60s, 60, 3600, and so on. So a wedge in the 60s column meant 60, not 1. This was far more powerful than Egyptian numerals for big numbers and calculations. However, they had one major flaw. For a long time, they had no symbol for 0. Later, they used a placeholder, 2 small angled wedges, but not as a true 0. Let's march forward in time travel west to the great Roman Empire. The Romans were famous for their roads, aqueducts, and armies. They needed a number system for organizing legions and recording events. Roman numerals used letters from their alphabet. We still see them on clocks and in names like Queen Elizabeth II. And for the Super Bowl, the system was based on 7 letters, I, V, X, L, C, D, M, using addition of values to write numbers. 3 is a 3, 12 is 14, 166 is CLXVN. They also used a subtraction rule. Placing a smaller symbol before a larger one subtracts it. Ivor =4, einth = 9. Roman numerals were terrible for arithmetic. Multiplication or division was a nightmare. To calculate, they used a counting board, an abacus, sliding beads and stones. Written Roman numerals were often just for recording final answers, not for working them out. A new, better system was needed before science and trade could truly take off. For thousands of years, mathematicians worked with a huge piece of their puzzle missing: They had symbols for 1, 10, 100, but not for nothing. They didn't have a symbol for nothing. The invention of zero was one of the most important moments in the history of mathematics. The brilliant idea seems to have come from India. Around the 5th century AD, mathematicians started using a small dot, a small circle. They called it sunya, empty or void. At first it served as a placeholder like the Babylonians had used. This was incredibly useful. It clarified place value columns, 32, 302, 320. The little circle showed nothing in the tens column for 302. This made their number system much clearer and more powerful. But Indian mathematicians went further and treated zero as a number in its own right. They understood rules. Add zero, number stays the same. Multiply by zero, result is zero. 5 plus 0 equals 5. 5 times 0 equals 0. It allowed algebra. X plus 5 equals 5 implies x equals sine 0. That humble little circle unlocked calculus, computers, and modern science, turning nothing into something important. With the invention of zero, Indian mathematicians had everything they needed. They created a fantastic number system by combining 3 ideas. They combined 3 brilliant ideas. First, base 10. Second, a positional system. Third, zero as placeholder and number. The result, just 10 simple symbols, 0 to 9, that can write any number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This efficient system began to spread from India across trade routes. Arab and Persian scholars and merchants adopted it and praised its power. Al-Khwarizmi wrote about it around 825 AD. His work gave us the word algorithm. In 1202, Fibonacci taught Europe how useful these numerals were. They made addition, subtraction, multiplication, and division far easier than Roman numerals. Al-Khwarizmi's work popularized practical calculation methods. At first, people were suspicious. Some cities banned the new numbers, but the advantages were too great. By the printing press era, the Hindu-Arabic system had won. Those 10 simple symbols spread globally and are the very same numbers on our keyboards and phones today. A small set of symbols that changed the world. Once the world had a simple, powerful number system with zero, everything started to change, and fast. Think about trade. A merchant could calculate costs of 1,000 bolts of silk, keep perfect records. This enabled banking, insurance, and complex finance. Then think about science. The scientific revolution relied on mathematics. Scientists like Galileo and Newton used math to describe the universe. From planetary motion to the speed of a falling apple and cannon trajectories, numbers made prediction possible. They allowed calculations and models to predict outcomes. Numbers enabled huge cathedrals, amazing bridges, and complex machines. Map makers created more accurate charts for explorers. Numbers helped farms and factories plan and optimize. Governments could take censuses to plan taxes, schools, hospitals. From bus timetables to recipes, numbers structured daily life. We built the modern world on a foundation of numbers. Numbers let us see hidden patterns in the universe. And the journey isn't over. Who knows what new ideas about numbers we'll find next? For centuries, people did maths with pen and paper. Then the 20th century brought a new revolution. Mechanical calculators with gears, then electronic handheld calculators arrived. You could solve long division in a fraction of a second. The real change came with the computer. Computers use binary, only 0 and 1. Every letter, picture, sound, and video is broken into very long strings of zeros and ones. A 1 means a signal is on, a 0 means off. By switching billions of signals on and off, computers perform vast calculations every second. We've gone from counting sheep with stones to carrying devices in our pockets that process billions of numbers per second. The story of numbers is the story of human ingenuity. From a shepherd counting sheep to rockets, cures, and global connections, numbers made it possible.